magnetic field focusing. Magnetic field focusing. An appropriate configuration of non-uniform electric field. An appropriate configuration of non-uniform electric field as seen in previous articles is used for focusing of electrons. An electron beam can also be focused with the help. An electron beam can be focused with the help of magnetic field. Depending upon the nature of the magnetic field and the direction of its application, two differential types of focusing are obtained. Okay, first longitudinal magnetic field focusing and second transverse magnetic field focusing. Okay, first longitudinal 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 magnetic field longitudinal magnetic field focusing longitudinal magnetic field focusing, and second is transverse magnetic field focusing. Transverse magnetic field focusing. Transverse magnetic field focusing. Magnetic field focusing. Magnetic field focusing. Transverse magnetic field focusing. Transverse magnetic field focusing. First point, longitudinal magnetic field focusing. Longitudinal magnetic field focusing. Longitudinal magnetic field focusing. Okay, longitudinal magnetic field focusing and transverse magnetic field focusing. First is longitudinal magnetic field focusing and second is transverse magnetic field focusing. Okay, then first point, longitudinal magnetic field focusing. Third point, longitudinal magnetic field focusing. Okay, then longitudinal magnetic field focusing. Okay, magnetic field focusing. Okay, in the first part, in the magnetic field focusing, the first part of magnetic field focusing, longitudinal magnetic field focusing. Then charged particle like electron can be focused at a point by employing a uniform magnetic field acting along the direction of motion of beam of charged particles. As shown the path of an electron. Okay, in a uniform magnetic field would be a helix. In a uniform magnetic field would be a helix if electron enter at angle phi. If electron enter at angle phi, the pitch P of the helix is given by P equal to 2 pi mv by EB cos phi. This is the first equation. Okay, suppose a beam of electron enters at point O. Suppose a beam of electron enters at point O with a small angle phi. And with a velocity small v, if phi is taken to small. If phi is taken to small 10 degree, cos phi may be taken as unity. Then cos phi may be taken as unity. In time t, the charged particles comes to focus at point P. The length OP equal to L. Length OP equal to L is given by L equal to 2 pi mb. 2 pi mb upon EB. This is the equation number second. This is the equation number second. Okay? This is the equation number second. Okay? Therefore, the beam of electron entering the field B making a small angle of divergence phi come to focus at a distance L or any point which is located at a distance of integral multiple of L is that L is that N M. Okay. Second point, transverse magnetic field focusing. Second point, transverse magnetic field focusing. Transverse magnetic field, transverse magnetic field focusing. Transverse magnetic field focusing. Okay. Transverse magnetic field focusing. This method is very useful in separating the isotopes. Okay, this method is very useful. This method is very useful. This method is very useful in separating the isotopes. In separating the isotopes. In separating the isotopes. Okay. This method is very useful in separating the isotopes. Or transverse uniform magnetic field can be implied to focus a beam of charged particles. The focusing would be affected after rotating the beam through 180 degrees. The method of semicircular focusing was first implied by Rutherford in 1914. Okay, the method of semicircular focusing or transverse uniform magnetic field or transverse uniform magnetic field or transverse uniform magnetic field can also be implied to focus a beam of charged particles. Focus a beam of charged particles. The focusing would be affected after after rotating the beam through 180 degree. The method of semicircular focusing was first implied by the method of semicircular focusing was first implied by Rutherford in 1914. Implied by Rutherford in 1914, okay? In 1914, if a beam are positively, if a beam, if a beam are positively, if a beam are positively charged particles, positively charged particles, positively charged particles with the same velocity, with the same velocity, same velocity, with the same velocity, fusing same velocity, using velocity selector, enter uniform magnetic field, enter a uniform magnetic field, enter a uniform magnetic field acting in a transverse direction, acting in a transverse direction, acting in a transverse direction, okay? Transverse direction to its motion, and if the angular divergence of the beam is very small, and angular divergence, and angular divergence of the beam is very small, phi is small, it gets focused after completing, it gets focused after completing a semicircle 180 degree, semicircle 180 degree, to separate and identify the isotopes of an element. Its atoms are ionized first, then allowed through a slit S into the region of a uniform magnetic field acting transversely, okay? The ion belonging to the first isotopes would have different masses, okay? Their even through having the same velocity possesses different momenta, and therefore come to focus as a different point. Let the particle are deflected with a large radius by capital R equal to mv by qb, okay? qb, okay? From previous lecture, okay? Then this is the slit S, and this is boxing, okay? Okay, point figure number A, and this is slit S, and the first is 1, and this is point P, okay? And the second point 2, and this is going to the point Q, and the third, this is third line that goes to point P, okay? 1, 2, and 3, okay? And S पौने 6 this देखो बाद में R. Okay, the angle is phi. Okay, and this is phi angle, and this is phi, and this is phi. Okay, and this is 2r. This is 2r. Okay, for the particles having different value of mv and the beam is not spread, the radius of the semicircle will be different. Okay, thus the particles having the same volume of mv will get focused after 180-degree deflection at the same point. This is called momentum selector principle. The particle having the same values of mv, the particles having the particles having the same values of mv will get focused after will get focused after 180-degree deflection. 180-degree deflection at the same point. This is called momentum selector principle. Momentum selector principle. Okay, and now consider that the beam is spread. The particles moving along path 2. The particles moving along path 2 are focused at Q, and particles moving along path 1 and 3 are focused at P. The distance PQ. The distance PQ equal to 2R minus 2R cos phi, that is 2R 1 minus cos phi. Okay, 1 minus cos phi. When phi is very small, then cos phi equal to 1 minus phi square upon factorial 2 plus phi to the power 4 by factorial 4 and dot. Okay, Isotropes are nuclei having the same atomic number Z but different atomic mass A. Isotrope are the nuclei having the same atomic proton number Z but different atomic mass A. The isotopes of an element contain the same number of protons but different number of neutrons. For example, oxygen has two isotopes, 8O16 and 8O17. Oxygen has three isotopes, 8O16, 8O16 and 8O17. Hydrogen has three isotopes. 1H1, hydrogen has three isotopes, H1 and 1H1, that is known as hydrogen, and 1H2, that is known as deuterium, and third is tritium, 1H3, 3. Tritium. Neon has two isotopes. Neon has two isotopes. 10 neon, 20, and 22 neon, 10. Okay. Chlorine has two isotopes. 35 Cl17 and 37 Cl17. Okay. It presents about 297 different isotopes are known. Okay. And cos phi equal to 1 minus phi square by factorial 2, phi square by factorial 2, and plus phi by phi to the power 4 by factorial 4. Cos phi equal to 1 minus phi square by factorial 2 and plus phi to the power 4 by factorial 4. Then 1 minus phi square by 2 approximately. Then PQ equal to 2R 1 minus phi square by 2, that is R phi square. As phi is small, then phi is square is extremely small, and the width of the focusing and width of the focusing PQ is very small. PQ is very small. Okay. All the particles having same momenta and charge will be focusing between PQ. All the particles having same momenta, having same momenta, all the particles having same momenta and charge will be focused. Momenta and charge will be focused. Charge will be focused between PQ. The particles having different values of momenta. The particles having different values of momenta, different values of momenta and charge will be focused at different points. Okay, different points. Therefore, this method is very useful in separating. Therefore, this method is very useful in separating. Therefore, this method is very useful in separating the isotopes. Therefore, this method is very useful in separating the isotopes. Okay. And next heading, mass spectrograph.